So hello everyone, this is Daniel from ENERZAi, and I'll be leading today's webinar on boosting generative AI performance on Snapdragon processors, especially focusing on AI inference optimization on Qualcomm's custom Orion CPU using our software Optimium. So first of all, thank you very much for your time today, and I'll begin with a brief introduction of myself and my team. So this is Daniel Chang again, and I'm the co-founder and CEO of ENERZAi. Our team ENERZAi is an AI startup based in Seoul, Korea, and we are a team specialized in AI inference optimization technology. We are a team comprised of 25 specialists, and we have 28 patents registered and 23 applied, which mostly are related to our core technology, which again would be our AI inference optimization technology. As for the details of the technology that we provide, I'll elaborate more at the later part of today's presentation. And as a background, right before founding ENERZAi, I was involved in one of the fastest growing AI startups in Korea, which was called SwaLab. While I was with SwaLab, my role was to develop business for deep learning-based vision inspection software, which was mainly used for manufacturing purposes. And in fact, SwaLab is now part of a Nasdaq-listed company as it was acquired back in 2019. And before that, I worked at SK Telecom, which is the largest telecommunication company in Korea. And it was a very meaningful time for me because I first had the experience to work with the AI developers and also deal with the AI products back then. So to start today's agenda, I want to introduce a trend which in fact will be very relevant to our daily lives. Over the past decade, AI has rapidly expanded beyond research labs and into products that we daily use, making our lives more efficient, connected, and convenient. And in fact, most of the products that we use every day are now powered by at least one AI function. And here are some examples of such products. So not to mention smartphones, which provides real-time voice assistance and face recognition to protect your privacy. And it now converts phone calls or even recorded meetings into text very seamlessly. And also laptops these days provide powerful AI functions to identify your face real-time, to protect your data being exposed to others, or you could search through files with interactive prompts. And furthermore, even refrigerators recommend recipes based on the food recognition outputs, and even vacuums are now smart enough to use AI-driven sensors and cameras to create indoor maps and avoid obstacles, and to analyze floor types to adjust cleaning modes automatically. And this is all thanks to the AI technology which is inside those devices. So we could say that it has become nearly impossible to find appliances or devices without any AI function, as these are now seamlessly integrated into the devices we rely on every day. So one case I'd like to deep dive into would be the AI-powered laptop, which Samsung released about half a year ago. I'm introducing this product as it encapsulates very interesting AI and diverse AI features, but also because it is the device that I will conduct a demonstration for you today. So Galaxy Book 4 Edge is a Qualcomm-powered laptop, which is equipped with Galaxy AI technologies, such as live caption that provides subtitles in real time for video calls, or even entertainment contents like movies. Also, it provides video enhancement functions that improves lighting or blur distractions during video calls. And on the lower part, it also provides co-creator function, which generates artistic images for your projects. Another cool feature that it provides is that if you cannot recall the exact details of the files that you're looking for, you could use a feature called Recall to simply describe how you remember it through a simple prompt and an interactive prompt, so that the Copilot would go through your entire files and get back to you with your past photos, links, or messages. So we've actually purchased this product for a live demo purpose to showcase our AI acceleration technology during CES last month. And as being a user ever since, I'm quite satisfied with what it provides. Now, given that AI-powered devices, including Galaxy Book 4 Edge, have to run all these AI models within this tiny little chip, it could be very natural for us to question how this could even happen. Especially considering that many models we enjoy through cloud services or gigantic data centers require portions of these enormous computing resources. It is truly amazing that those appliances and gadgets could do the same. So my view for this is that it is truly a pinnacle of innovation, which involves both groundbreaking hardware and groundbreaking software technology into one. So to look into the hardware perspective first, Galaxy Book 4 Edge that I've introduced previously is powered by Snapdragon X Elite. And this chip is a powerhouse system on chip for Windows PCs, featuring Qualcomm's custom 12-core Orion CPU, paired with Qualcomm Adreno GPU delivering up to 4.6 teraflops. But the real mind blower here is its 45 TOPS hexagon NPU, which Qualcomm promotes as being 4.5 times faster than its competitors. On top of this hardware, Qualcomm also provides powerful software toolkits, such as Qualcomm AI Stack, where you can convert and deploy AI models on Hexagon NPU. Having in mind that Galaxy S4 Book is powered by this platform, we might now understand that Copilot PC could how that Copilot PC could actually power so many AI models for its users. Then would a powerful NPU like Hexagon be the master key of AI enablement on device? First thing we should consider is that not all appliances and devices are equipped with such high-end system on chips. However, I'll cover this issue at the later part of my presentation today. And now I'll stick to cases which leverage high-end platforms just like X Elite for now. So one case that we've witnessed among conducting many projects, many AI projects and deployment projects, is that even though the NPU itself is super powerful, it might not be enough once too many jobs are burdened to that single AI chip. In this case, some of the models might have to be migrated to other inference options, such as CPU or GPU, which would be Orion or Adreno here respectively. However, given that these chips are not AI inference oriented, unlike Hexagon NPU, it would require a more keen approach to successfully deliver the best AI experience to its end users. So here's where the software level approach must come into play. The typical approach that we could first consider is applying model compression techniques such as quantization and knowledge distillation and pruning. And in fact, as a startup specializing in inference optimization and inference efficiency, we have very often applied these techniques for a number of our projects. And the common issue that we faced was that for some cases, these approach might negatively impact the model's accuracy, so the pre-trained model's accuracy. But more importantly, even though these techniques were delicately applied, in many cases, the model compression itself wasn't enough to meet the mass production target of our clients, considering that the AI model had to be deployed on GPU, the mobile GPU, or the CPU. So we always needed something more to push further than that. And also considering that the models that are largely used these days are very large, like dealing with like 7 billion or even like 405 billion. Even though we compress those models or quantize those models into like integer 8 or lower than that, there won't be enough to meet the mass production targets in terms of latency. So in these cases, a good inference framework or an inference backend could come into play. So the most widely used inference framework for AI projects on device, CPU, or GPU would be TensorFlow Lite. Also, you could integrate inference backends like XN and PEC along with TensorFlow Lite, especially for ARM CPU inference. XN and PEC is a backend comprised of highly optimized network inference operators to achieve further acceleration of your AI models on especially CPUs. And one more interesting project I could share is ARM's Cloud AI project. And this Cloud AI project goes even further than XN and PEC, as ARM open sourced a set of microkernels specifically targeting the architecture which they've designed themselves, which would be obviously ARM CPUs. So ARM collaborated with Google, as far as I understand, to integrate Cloudy AI into XNMPEG. So once you update to the most recent XNMPEG version, you can enable Cloudy AI for better inference using XNMPEG on ARM64. However, obviously, there's one inference option which outperforms all the options I've previously mentioned. And it's the software that we're building right now called Optimium. So Optimium is an inference optimization engine, which we've built on top of our proprietary programming language called Nadia. And I won't go into too much of a detail with Nadia for today, but to briefly share, it is basically a programming language that we developed to focus on AI inference optimization, solely on AI inference optimization. So it's Nadia's powerful metaprogramming functions enable us to push the inference speed of the models as much as possible here. So if you have any further inquiries regarding Nadia, you can ask as a follow-up question after this presentation, or you can also visit our tech blog after this event, which I'll be sharing the link at the latest slide of this presentation. So to go into more details of the software called Optimium, Optimium is actually comprised of three main parts. So the three key modules, which are Graph module, and Nadia compiler, and runtime module. So we currently take pre-trained PyTorch models or TensorFlow Lite models as an input. And once the pre-trained model is ingested into Optimium, we first convert all the layers to Nadia layers, Nadia described layers, or I could say Nadia expressed layers, so that we could proceed with our unique optimization pipeline. The graph module then conducts somewhat high-level or structural analysis automatically on the input model, and then automatically finds layer fusion options. So one of the most distinctive parts of Optimium is that it conducts optimization by connecting the target hardware to Optimium. So for example, once you install Optimium at your local PC or your local server, which will actually be your development environment, and try to optimize your model, which will eventually be deployed to Qualcomm-powered laptop, that laptop will become your target device. And we connect the target device to your local PC or local server, again, will be your development environment, and conduct customized optimization on top of the hardware information provided from the Qualcomm-powered laptop. To do this, you will have to install Optimium runtime and the remote server at your target device. And once installed, it will conduct an interactive optimization based on the runtime execution results, which is profiled repetitively until we go through the entire search space of optimization parameter combinations of layers, so each and every layers, and come out with the optimal option layer by layer. So obviously, as we use Nadia language for this process, Nadia compiler plays a key role in mediating the entire process. And once this process is over, we'll have an optimized AI model as an output, which is actually an accumulation of highly optimized operators. So here are some demo videos of our optimization outputs. For both videos here, there's some kind of a lag, but in some frames you can see the difference here. So for both videos, the left will be the real-time output of a MediaPipe model deployed on ARM-based CPU using XNMPEG backend. And the videos on the right are the outputs of Optimium. So you can see this frame by frame, but not dramatically, because I think there's some kind of a lag here with my presentation. But later on, when we upload this video on YouTube, I'll attach the demo videos here so you can find out yourself through YouTube. So again, on the left is the XNMPEG optimized result, and the right will be Optimium optimized result. And as you can see here, the XNMPEG backend is dropping some frames, frame by frame, which could eventually harm the quality of AI products, AI power products, which use XNMPEG as an inference backend. Whereas the Optimium output successfully detects the phase landmarks on the left and the pose on the right real time. So this could actually emphasize which tool or inference backend you choose to deploy your models on CPU could dramatically impact the project's overall performance. And as I've mentioned previously, not all SoCs are equipped with powerful NPUs as Snapdragon X Elite. So some SoCs might even lack AI chips, or even though they have one, it could have a very narrow scope of coverage in terms of operator or layer support. And in this case, those unsupported models or part of those models should be allocated to other inference options. And it's a very common case for us as we do a lot of AI inference optimization projects on various hardware. And I would like to highlight today our two approaches which we commonly take. First, as Optimium currently supports a powerful inference backend for CPUs, we could entirely allocate the model to CPU. So to overcome the hardware limitations compared to NPUs in terms of AI inference, we go through the optimization workflow, which I've shared in the previous slides. Here are some sample benchmarks on the top, which Optimium actually outperformed other inference optimization options on diverse CPUs, even including ARM-based server CPUs like AWS Graviton, and on-device CPUs like the Snapdragon Orion CPU, which we will demonstrate today. Otherwise, the second option would be we could also leverage heterogeneous execution by using both CPU and GPU for inference. So I've briefly illustrated here below a case which we've actually maximized inference performance by doing so. So to go into more details, we've actually split the model into 5 parts and then allocated the first and last portion of the model to GPU and parts 2 to 4 to CPU after conducting optimization using Optimium. As Optimium did not support GPU for now, but we plan to do so in the near future. But for now, we use TF-Lite Delegate for GPU execution for part 1 and 5, while fully optimizing parts 2 through 4 to run as fast as possible on CPU. So overall, the process has been accelerated 3 more times than using a single inference platform with other inference software. To elaborate, as we are leveraging 2 discrete chips, portion number 1 could be executed on GPU, as you can see in this slide, on the lower part of the slide. So the portion number 1 could be actually executed on GPU, while numbers 2 through 4 are actually being executed on CPU. In fact, making the best out of the computing resources provided, like the case I've just illustrated, is exactly what we do the best. So finally, I'll just briefly run through a demo on how you could actually optimize models yourself using Optimium. So the demo scenario is illustrated here in the slide. I'll use my host PC, where Optimium is already installed, and remotely connect to the target device, which will be Snapdragon X Elite within Galaxy Book 4 Edge in this case. So basically, the remote server is pre-installed within Galaxy Book 4 Edge, which will be used for today's demo. So I'll stop sharing the slide for now. So I'll just briefly run through. So here, actually, so we'll first, I've activated the host PC, which would be the server that Optimium is pre-installed. And here, through VS Code, I'll activate the remote server, so which will be the Galaxy Book 4 Edge that our Optimium remote server is already installed. So to do so, we will open it by typing in its address. And once we activate it, then the remote server and the host server actually, which the Optimium is installed, is now connected. So we're ready to go and ready to auto-tune using Optimium so that it could it could be very fit to the target hardware, which is Snapdragon based. And then coming back to our local host PC, I'll start importing Optimium here. So I'll import Optimium. And then Optimium itself is very automatic, so it's very simple to use. You could simply type in the prompts, answer the prompts that's provided, and it will automatically create a template that you could start optimization with. So I'll start with the creating the template. So as I've mentioned, there will be a prompt asking to type in the device name. So in this case, as we are optimizing on top of a Snapdragon X8, I'll type in Snapdragon. I'll just go by default, and we'll be optimizing today a decoder from a stable diffusion model, and it's in the form of a PyTorch model. So the framework we select will be PyTorch, and then in fact, right before this creating this template, I've already activated the remote server, so it is remotely connected. So we could collect all the information from the target device, which will be the Galaxy Book 4 Edge, and then start optimizing on top of it. So the address of my remote server, the Galaxy Book 4 Edge, would be as such. And also, since it's ARM-based, I'll just type in ARM instead of x86. And since it's not a Cortex-M based chip, I'll say no. And I'll select OS as Linux, even though the Galaxy Book 4 Edge is a Windows PC. Since Optimium currently only supports Linux and Android platform, we've activated WSL for this demo. So I'll select Linux for WSL. And also, Optimium actually automatically collects the attributes such as neon from the target CPU currently. And we do this automatically, so we highly recommend using yes, so that Optimium can actually fetch those attributes for you. But if you type no, you will have to manually specify all the desired attributes you would like to leverage. And for today's demo, I will leverage 4 cores of Orion CPU, so I'll type in 4. Skip that part. And the entire pipeline that I mentioned through the presentation is actually a process called auto-tuning. So we automatically designate the optimum parameters for each and every layer. And we highly recommend you doing so. So I'll say yes for auto-tuning, and you're ready to go. So once done, once you follow all the prompts here, you can see a new user arguments JSON file has been created. And all the attributes that you've typed in, you followed through the prompt, has been written here. So the address for your remote server has been typed in, and the device name, the Snapdragon device name, is here. And the framework of this model, the PyTorch model, has been successfully and automatically being applied to this automatically created user arguments JSON. So this will be the baseline and the template that the entire automation process will begin with. And in order to actually, I've mentioned that we take PyTorch models and also TensorFlow Lite models, but as for PyTorch models, we don't have to manually fix any of the options here in the user arguments file, but rather we'll need some more Python codes for that. So here's the example for such Python codes. And as I've mentioned, we'll be leveraging a stable diffusion model. In fact, we'll be optimizing a stable diffusion model, and more specifically, we'll be optimizing the decoder part of it. So I've specified the model ID here. And we are here using the diffusion library through Hugging Face. And also, so this is the most important part. You have to call the model and also the data inputs to kickstart your optimization process. So based on this sample Python code and the user arguments JSON file that has been created, we're now ready to go start the optimization process now. So all this done, all this has been conducted very simply. So we'll now kick off and start optimizing the stable diffusion decoder right now. And most importantly, it will be optimizing specifically targeting the Orion CPU and 4 cores, as we've designated that we will be using four number of threads. Okay, so now I'll start. So I'll start the Python code that I've written as a sample Python code. Oops, there was a typo. Then it will start automatically tuning the model on top of the hardware provided, the target hardware provided. So, in fact, to share more information, we're currently running a beta right now. So if you sign up for the beta through the Typeform template that we have, which I'll be sharing as a QR code after this demonstration. Once you sign up, we'll send you a license key so that you could use Optimium Beta. And I've already created the license key for the purpose of this demo. And I'll just copy and paste that license key here. And once you provide the right license key, it will automatically start tuning, auto tuning. So basically, it will be optimizing layer by layer. So this decoder itself, not the entire model, is comprised of 148 ops. So it's tuning the first operation, and it goes to the second one, and so on until you finish optimizing the entire layer provided. However, as for your information, currently the entire tuning process, the compilation process, or so to say, the optimization process, it takes quite long because it goes layer by layer. So I won't go through the entire process right now. I'll just stop in the middle of the tuning process and then move on to the already optimized Stable Diffusion decoder demo soon. But I'll stop here since it takes too long. But for your information, we are currently preparing a major update of Optimium Beta, which will be completed next month during March. And once we do so, it will minimize the compilation process dramatically. So it will be very faster than now. So maybe I could demonstrate that through a webinar in that once we're ready for that. So, but as for now, it takes quite a time for the compilation process. So I'll just stop here. And now move on to showing you the results of our optimized output. So I'll go back to the So, in fact, our CTO, Jay, is helping me out for today's webinar. And I'll briefly introduce the demonstration that I will show you today. So we have two Galaxy Book 4 Edge laptops here ready. So it's totally identical. It's the exact same laptop using Snapdragon X Elite. And we're demonstrating a Stable Diffusion model here. And obviously we've accelerated using Optimium. And as a background, the left laptop is the model as is. So it's the PyTorch model, the Stable Diffusion model, running on top of Orion CPUs, specifically 4 cores of Orion CPU. And we already prompted here, as you can see. And on the right is the exact same model using the exact same 4 Orion CPU cores. But the only difference is that this is the model that we optimized using Optimium here. So I'll just write a prompt here. Red tomato. And I'll write the exact same prompt on the right, which is the version that we optimized using Optimium. And then I'll run it at the same time. And as a result, you would see that the laptop on the right, will be executing the output, the Stable Diffusion output, approximately twice as faster than the Torch model on the left, even though it's using the same number of Orion CPU cores, which is 4 cores. You can expect way more faster output and exact same output here. In fact, the PyTorch model had some problem. It's not okay. So as you can see, the original model, it took 30 seconds to create this image, whereas uh, the exact same model, but optimized using Optimium, took only 10 seconds generating this red tomato image output. So we have froze the seed, so it should have the exact same output, which would be quite different from the quantized outputs. Let's say if we quantize the model too much, the output quality, the image quality might be very bad or very different. But as you can see here, we've accelerated the model a lot while preserving the image quality here. So maybe I could try another prompt here for the sake of the demo. So I'll just write Tesla and also the same prompt on the right. Yep. And do the same. And it will have the approximately the similar output here as well. So considering that these kind of AI-powered devices, they have a limited resource, but they have to deal with a lot of models, and you at the same time you want to meet the target, like production target, to satisfy your end users. Using the minimum core as possible to have the maximum output is very important, and I could say that Optimium is doing so here. So here again, it took 20 seconds to generate the image using 4 cores, but it took 10 seconds to generate uh, using the same number of cores here. So I'll just stop the demonstration here and go back to the presentation. So, okay. So, as I've mentioned during the demo, we're currently running a beta. So if you follow this QR code, you can sign up for a free trial of our beta if you want to try out Optimium for your own models and your target CPU. That's because we only support CPU for now. And also, I shared here my email address along with our website and also our tech blog URL, the link up for our tech blog. So you can find out more through our website and our tech blog for more details about Optimium and also the language that I shared very briefly today, which would be Nadia. Nadia is more elaborated on our tech blog, so and I highly recommend you finding out more there. So it was a brief introduction of our product and a brief sharing our live demo here. And I want to sum up right here. So I hope today's session was helpful for you. And again, we specialize in making the best out of the provided computing resources, let's say like low-end SoCs or even high-end SoCs. So please feel free to reach out if you are building any AI projects on top of any SoCs or even low level SoCs which do not have any AI chips. Or given that we support CPUs, we do not we also support server level CPUs, let's say like AWS Graviton instances or Google's Xeon instances. So if you are to have any projects there, you could also reach out to us to make the best out of your models without compromising accuracy. And one more thing I'd like to share is that we'll be attending MWC next week and also the Embedded World the week after. So let me know if you like to chat there. You can always email me. So this is pretty much what I've prepared for today. So I'll be more than happy to answer any questions if you have any. Oh, I think I need to activate the microphones for you to ask questions if you have any. I'll just try that.
Yeah, I think the microphone is already active.
Oh, okay, great.
I came late to the event, so I don't want to have any questions. I've got to go back and watch the recording, and I'll
Okay,
email you.
great, perfect. So I guess there's no questions for now. So as you've mentioned, you can always email me or contact us through any channels. Actually, our website has a contact channel there, so just let us know anytime. And again, I think if there's no questions here, we can wrap up here. And again, thank you for your time today. And I'll be hoping to meet you all again. Okay, thank you very much.